This is our third video in the definite integral, and this video talks about units and properties of integrals. So, in many of our integrals from a to b of f of x dx, f of x and dx have their own units. The units of the definite integral are just the units of the product of f of x and dx. So let me show you a couple of these just so you'll know where the units come from. So in this case, if f of x is in meters per second and dx is in seconds, what will be the units of this? Well, all you do is multiply them. So if f of x is in meters per second, we're just going to go, okay, this is in meters per second, and dx is in seconds. When I multiply them, these cancel out. My answer is going to be in meters of my integral, if I found it. In this one here, if f of x is in centimeters, so this is in centimeters, times, and dx is in centimeters, so we're just going to multiply them both. My units of my integral would be centimeters squared. Okay. If this one, the units were in people per square mile, and dx was in miles, I would have people per square miles times miles. So my answer would be in people per mile. I think you get the idea. Is whatever the units of your f of x are and my dx, you just multiply them, and that would be the units of your integral. Okay? What I want to spend some more time is the actual properties of integrals, and I think this is kind of cool. So before I even do this, I'm going to let you look at these two and tell me what the difference is. So this one's the integral from 1 to 3, so I'm going to highlight this. And then this one is from 3 to 1. The f of x is the same and dx is the same. All right, so just see that. Now if I put this in my calculator, I'm going to get a 16 when I evaluate it. When I put this in my calculator, I get a negative 16. And if you'll notice, the only thing I did was switch my beginning and ending point. Okay, this is called the order of integration. So what you can deduct from this is you can make a negative out of anything by just switching the beginning and end and start from 3 and go back to 1 versus from 1 to 3. Okay? So if I had an integral from a to b of f of x dx, okay, that equals the negative of from b to a. So you just start at the end and go to the beginning. It's opposite. That's the order of integration. All right, now let's look at these three and see what we have here. So they're all same function, they're all dx. So this got to be with, this one goes from 1 to 3, this goes from 3 to 6, and this goes from 1 to 6. So this one right here is like the total of those two. Let's see what happens. When I put this in my calculator, I get 16. When I put this in my calculator, I get 46.5. And when I put this in my calculator, it's 62.5. which is the total of these two. So what can we deduct from this as an property, if you will, is this is called additivity. That if I take an integral from a to b of f of x dx and add to it an integral from b to c of f of x dx, it's going to equal the whole thing, a to c of f of x dx. That is additivity. Okay, let's try some more properties here. If I want to evaluate from 3 to 5 x squared, so I'm looking at this, so I want you to notice that all of these have 3 to 5. Okay, here's this function x squared, here's this function here, and then this is the total of these two added up. So when I do to 3 to 5 x squared, I get 32 and 2/3. When I do this one from 3 to 5 of 2x plus 1 dx, I get 18. When I put these two together and come up with this, I get 50 and 2/3. Okay? This is called the sum and difference, and you can do this with integration as long as you have the same interval. Notice they're all 3 to 5. If you did that, you can take functions and combine functions and see where if you add them, you'll come up with a sum. If you subtract them, you'll come up with the difference. And that is another property of integration. Let's look at this one here, and then we'll kind of do a summary. I have from 3 to 5, so that matches, of 3x squared. Here, all I did was pull the 3 out front. So if I did this one right here, I get 98. Here, if I say 3 times the integral of that, I get the same thing. This is called the constant multiple rule, where you can pull out the constant out front and then do the integral, get the same thing as having that constant inside. So I have a summation of this all down here. We have the order of integration, so this is the first one that we just did, okay? Zero width is that if I went from A to A, meaning my interval didn't change at all, it's the same number, it's going to be a zero width right here. My answer would be 0. Here, this one's a negative. The constant multiple, I showed you that here's your constant here. You can bring it out front and get the same thing. If you had a negative here and put the negative out front, it's like -1. That works too. You have sum and difference, where if you have the same interval here, you can either add or subtract them. We talked about that. We did additivity, where you had from A to B, and then we got B to C of the same thing. We can add them all up from here. And then we did max and min. Well, I didn't show you this one here, but if it says if the max value of max of f and the minimum value min of f on this, then you can say the min of f times b minus a is less than this, and it's less than the max of that. And then we have this other case called domination. I don't really spend a lot of time on these two right here, but I wanted you to have them for your notes. Okay? So we're going to practice some of these properties in class, but I'm going to tell you that you can not necessarily know what the functions are and come up with answers with integrals by just knowing the properties. So that's the end of this video.